our channel Euclid Mathematics. We have started lecture series on GATE previous year question papers. So within that I have already uploaded plenty of the videos on my channel. So if you wanted to see this video, you may check it into my playlist. Now in my today's video, I'm going to explain to you all one of the question from GATE previous year question paper. Which is we have to apply some of the questions, some of the concept from integral equation subject. Okay, but question it is from the linear algebra. So these are interconnected questions. So that means this, for solving this single question, we have to know the concept from other subject too, like integral equation, like a linear algebra. Then you are able to solve these questions. Okay, questions are quite easy if you are familiar with some basic concept. Okay, now let's get started on today's question. I'm going to explain to you all first of all question, and then we'll move for the solution. Here what we have in our question, we have continuous function over closed interval 0 1 be the real vector space of all continuous real valued function. Okay, so we have continuous real valued function over closed interval 0 1 given. Okay, on closed interval 0 1, and t be the linear operator. Okay, so we have given this t, which is a linear operator. That means a domain and codomain is having same dimension. Okay, so dimension of a domain and dimension of a codomain exist and which is equal, then we say that t is a linear operator. Okay, on continuous function on closed interval 0 1, and which is given by t our function t of f of x is given integral over 0 to 1 sine of x plus y dy. Okay, and x belongs to closed interval 0 1. Okay, then we want the dimension of a range space. Okay, dimension of a range space of a t. So dimension of a range space, for finding the integral equation like this, we have to simplify this integral equation. We have to find out how many constants are there, how many trigonometric terms involved there. Then we have to find out the dimension of our range space. Okay, dimension of a range space means it's a rank. You have to define rank of our given integral equation. Now if you going to observe our integral equation, it's look like a Freedom integral equation. Okay, Freedom integral equation, what it says that when we have limit a to b fy dy, okay, then we say that it is the Freedom type of integral equation, because both of these are constant. That's why Freedom. If one of them it is getting to the x or like a variable, then we say that is a Volterra type integral equation. Okay, so we have given Freedom type of integral equation. Okay, and a solution for Freedom type of integral equation. How can we write the solution for Freedom type of integral equation? So for writing solution for Freedom type of integral, we'll get, okay, so I'm explaining general case how we get the solution in general. Okay, for Freedom type of integral equation, so we can write c1 something function over here, c1 f1x plus c2 f2x. Okay, so this is the type of a solution which we will get from our Freedom type of integral equation. Now how we will get, let me explain. So here in our integral we have given integration 0 to 1. Okay, integration 0 to 1 sine of x plus y fy dy. Okay, so this one is the integral we have given. Okay, so how can we say that it gives us the solution in the form of the c1 plus some function and c2 plus some function. Okay, we need to know the solution first. Once we understood the solution, then it is easier to find out the dimension of a range space. Okay, so we have integral 0 to 1 sine of x plus y fy dy. Okay, and as we know that sine of x plus y can be written as sine of sine x, sine a plus b, sine a cos b, so cos y plus cos a cos x sine y. Okay, so I'm gonna get that sine of a plus b as sine a cos b plus cos a sine b. Okay, so integral over 0 to 1 can be written as integral over 0 to 1 this way. Okay, so integral over 0 to 1, this addition means integral over 0 to 1 sine x cos y in the form of fy dy. We have here fy dy. Okay, sine x cos y fy dy plus integral over 0 to 1 cos x sine y fy dy. Okay, now here we can see with respect to y, sine x is a constant. Okay, so sine x it will come out. Okay, so sine x consider c1, we will get the sum integration 0 to 1 cos y fy dy. Okay, we get the some kind of integration over. We do not have to find out the solution for our Freedom integral equation. If you wanted to find, you may go for the solution of Freedom integral equation, but we don't have much time that we can solve Freedom integral equation, because Freedom integral equation for solving it take much ample of a time. Okay, so we cannot solve this question at the timing of exam. So we have to visualize how we will get the solution for our Freedom integral equation. Okay, now here sin x is a constant with respect to dy, so I consider it is a c1 as a constant. So we'll get the some kind of integral over it, 0 to 1 sin x cos y of y dy. Okay, so you consider that integral in the form of f1y plus, so we'll get the integration of this one after putting the limit f1y, maybe it is a constant, anything. Okay, f1y, again cos x is a constant with respect to fy. Okay, so cos x, take it outside, you will get the cos x as outside as a consider c2. Okay, it is cos x is a constant, that's with respect to y, so consider it is the c2 plus the integral over 0 to 1 sin y of y dy, you will get the f2 of y. Okay, so consider it is a f2 of y. Okay, so here we can see t of fy is the solution in the form of c1 f1y plus c2 f2y. Okay, c1 c2 constant, f1y f2y. Okay, and dimension of a range space, it says that rank of our given solution. Okay, so rank means here we have number of non-zero function which available over here. Okay, or it is the linear combination of a c1 f1 plus c2 f2. So f1 and f2 are bases. How can we find bases in linear algebra? For finding the basis, so we consider, as if you have polynomial a0 plus a1x plus a2x square plus so on, p of x as a polynomial. For finding the basis of our polynomial p of x, we write the basis as a coefficient of a constant. So constant has a coefficient 1, a0 has a coefficient 1, so first basis I got 1, second coefficient constant of coefficient of a1 which is x, and next coefficient x square, and so on. Okay, these are the basis of our polynomial. Okay, so similarly basis for our t of fy, f1y and f2y. Okay, f1 and f2 both are the basis. So number of bases, how many here? 2. If number of bases is 2, that means we have 2 non-zero rows and non-zero column in our given matrix. Okay, so if 2 non-zero row and 2 non-zero columns are there, then we say that dimension of a row range space. Okay, that means dimension of our t of f of x, which has a range space and which is the 2. Okay, understood how I written that dimension, which is the number of bases which is available over in our function. Okay, so as we found that by dimension basis by in our linear algebra. Okay, so basis for this polynomial 1x x square and so on. So basis for similar, apply this condition over here. Okay, so t of fy consider as a polynomial and the constant into f1y, constant into f2y. Okay, so f1 and f2 are the basis here and number of bases is 2. Number of a non-zero basis is 2, and if number of non-zero bases are 2, then we say that there is a dimension of a range space which is a rank which is a 2. Okay, so for your better understanding, you may refer my solution over here. So I solved this one here. Okay, might be my solution is different than my explanation. Okay, because I am using every time some other concept to solve our questions. Okay, so here we can see Freedom type of integral equation, this one. Okay, so constant into first function, constant into second function. So first basis, second basis. Now in next step, here we can see next step. So I written c1 sin x plus c2 cos x. Okay, this is the spanning set. Okay, spanning set means is a linear combination for linearly independent vectors. Okay, so c1 sin x plus c2 cos x, this is the linear combination for c1 and c2 with the sin x cos x. Okay, which is a spanning set. If it is from the spanning set, that means there exists a basis with respect to c1 and c2, which is sin x and cos x. Okay, so I have two bases, sin x cos x, with respect to this polynomial. So number of bases is 2. Okay, that means dimension of range space which is a rank, and dimension of number of bases here as a dimension, we say that it is a 2. Okay, so our no answer type question answer is here 2. Okay, I hope you all have understood my today's lecture completely based on the basis, dimension of a range space and a spanning set. Okay, So even after, if you found anything difficult, let me know in comment section. I will come up with some other videos. So thank you everyone. Thank you for my today's lecture.